Hello? Hello? Can you hear me? Am I here? Am I? Hello? Hello? Good morning, everyone. Can you hear me well? This microphone is not. Yes. All right, I'm here. Hello. Good morning. Good afternoon. Good evening. I see some people from Australia, which I believe is midnight right now. Ha ha ha. Fanny, ejército estaba listo. Yes, Chandra, we're all ready for this. Let's go. Let's do it. Whoo, whoo, whoo. Computational design. Ahoo, ahoo, ahoo. All right. I have clearly had too much coffee this morning. Even though it's decaf. But, um, but, um, but yeah, how is everybody doing? I'm going to take a quick look at the chat. Uh, awesome. Yes. All right. Uh, Good morning. Hey, Daniel. Good morning. How you doing? All right. So, as usual, as I tell you, like I know that there's roughly 50 people right now watching, but I don't know who you are. I can't see you unless you say hi on the chat. Um, the Cactus 90, is that a cis? Maybe? Hmm. Okay, so unless you say hi in the chat, I can see who you are. So feel welcome to like say hi to each other. Where you're coming from? What are you doing here? Why do you even like bother watching these streams? I don't even know why you guys do it, but I mean, I do it because I have a lot of fun doing it. So, so yeah. Oh, so it is you, Aziz, huh? All right, wonderful. Hey, Kristen, how are you doing? I see a lot of familiar faces. Jeremy, oh, I'm gonna talk about your contribution in a second. Yes, uh, awesome. And Pix, Pixel Car, I've been seeing you around a lot. I think we need to touch base at some point and say hi properly. Andres, hey, from Monterrey, buenísimo. Ah, all right. Okay, so I have a bunch of news, comments, things that I want to touch upon before we get into the actual stream. So, quick recap what we're going to do today. Oh, sorry. What we're going to do today is I'm going to do a quick round. So today's going to be like a bit of like an introduction to how C Sharp works inside of Grasshopper, and I would like to do that by doing a very simple but very, very good exercise, very good educational exercise of going through some regular vanilla Grasshopper components and then figuring out how we could implement that exact same functionality but with C Sharp script components. That is a very, very useful exercise to do because it lets you learn the basics of how C Sharp works in Grasshopper, but it's also a really good exercise in terms of like programming components and like making sure that things work correctly, checking data, adhering to data structures. It's a really, really good exercise. It's such a good exercise that is something that I've done with a group of my students at Harvard, and we actually have a project going on right now, which I will talk about in a second. But yeah, so okay, but before that, I have a bunch of things that I want to go over. I wrote myself a tiny list here. Yes, so things that have been going on lately around here. I this week an active design GSD Harvard. Um, this last Wednesday, I just wrapped up the seminar that I'm teaching at the Harvard Graduate School of Design right now. It's called An Active Design, and it was a seminar. It is still a seminar on human machine interaction and figuring out how, in the communication between humans and agents that have some kind of autonomy, you can call those machines, you can call those robots, you can call those machine learning models, neural networks, whatever, how we can find creative space and how can we find collaboration between them. It's been a really, really interesting seminar. I'm very proud of the work that is going on with my students right now there. Um, it's been a little bumpy with all the situation that we've been living through. So some of my students were actually working with robots, but then we had to shift to neural networks because like I mean we didn't have access to physical robots anymore. But it's been great, and I hope to we have it was the last class this Wednesday, and I we will have the final review Wednesday in 2 weeks. So hopefully, in a couple of weeks, maybe I can share some of the work that the students have done, or I can point you to resources where you can find. If you want to know a little bit of what the course is about, you can go to the course website, and there's like a small presentation. And it's been a really interesting uh, project in general. I also gave a lecture on machine learning for architecture, design, and art. I gave it at CS 109B, which is a data science here at Harvard. It's a data science class here at Harvard run by Professor Paulos Protopapas and his team. And it's a really interesting exercise. It's a really interesting class. It's an introduction to data science with a very strong focus on machine learning. And I gave like a couple lectures on like how I see the field of machine learning having potential in architecture, in design, and how we are creative. I'm not sure if I can share those lectures or not, but I'm gonna think about that, and maybe sometime soon I can share them, or I can make the public, or I can just give those lectures here in the channel. Is that something that you guys would be interested in? Are you interested in machine learning? I'm very interested in machine learning. I think it's very cool, and it has lots and lots of potential. Uh, so just say thumbs up, thumbs down if you want in the chat. Um, Also, I'm very happy. I have been receiving a lot of work and a lot of contributions from the community after all these streams. So, so for example, I want to point. Um, I can't. So I've like Hari Prasad and and Baba Kumaravel. They took the game of life exercise that we did last week, and they extended it to like grow over in the 3 dimension, or to implement the same rules of 2 dimension, and the same rules of survival and death, but instead of in a 2 dimensional grid, in a 3 dimensional grid. Are you around here, Hari Prasad? Are you here, Baba? Are you somewhere? If you guys are here, maybe you can say hi. Um, and so I would like to say that I really, really like when you guys do this, when you take what you've learned and you push it forward, you push it further, and you make cool stuff with it. If you publish, if you put these things on social media, I'm going to invite you to tag me or to tag the channel at some point, so that I can then forward these things and I can repost them. The way Instagram works is that if you, Baba, I see you there. Hi, thank you. The way that this works is that if you do an Instagram story, and if you don't tag me, then I cannot repost it. So I think reposting is great for everybody. So um, this is my open invitation. I also want to share a couple files that I have received from some folks. So, for example, Hari Prasad, he sent me his 3D version of he sent me his 3D version of the Game of Life, which I believe. Is this going to work? No. What is this? Uh, oh no! Wait. This is. Is this my file? Is this his file? Uh, I thought he did. Yeah, I thought he did the 3D version. Um, is this your file, Hari Prasad? I see you down. I see you down there. Why is it not working? Oh, okay. Yeah, I see. Um, yeah, I don't know what I'm doing. I don't know why it's not working right now. But 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 yeah, I actually made some changes, and I turned it into cubes. I don't know why it's not working. But anyway, it's very cool and it works really well. Maybe he can share it on the chat, or maybe he can. I'm gonna talk about that in a second. But I also received a really cool file from Jeremy, who I believe is on the chat as well. Jeremy, if you want to say hi to all of us. So he went ahead. He sounds to me like he is a very skilled Grasshopper user. So he went ahead and he actually implemented, let me zoom in here. He actually implemented the game of life, the two-dimensional grid, but he tried to do it just in purely with pure vanilla Grasshopper components, and they use and with the help of some plugins. But what you can see is that in this file he implemented everything. What is going on with my Grasshopper today? Why is this not working? Is my Grasshopper not working today for some reason? I know I have to reset. Run. Okay. Yes. And then, so he actually implemented Game of Life purely with Grasshopper components. And I actually want to commend you guys to check out his file because he did like a really smart data tree manipulation. So he worked with the data tree to figure out the two-dimensional grid. I thought it was really, really cool. And I was telling him like how I just code so much and I use C# so much that to me it wasn't even thinkable that it was possible to do just with plain Grasshopper components. He is making use of Anemone, which is a plugin that allows you to do for loops, which I believe is essential if you want to do this. But it was really, really cool. Which leads me to a question that I would like to address, and it is that if you guys actually want to contribute files and to share them with the community, so far in the channel we don't really have a formal way of doing that. I'm working on making that happen. I'm going to talk about that in a second. But I think that for the time being, I'm going to invite you to just create some kind of Google Drive link or Dropbox link or something that is permanent to the files that you want to share, to your examples, and then maybe post them as a link in the comments of this video or in the comments of the videos. We are working on figuring out a way to accept your incoming contributions and put them as part of like a central repository. We're also working on having some kind of like more permanent conversation platform to build community. So something like I'm actually thinking about Discord, starting a Discord where we have channels and we can share files and we can talk about future streams and themes. So that will hopefully happen sometime very soon. But in the meantime, you can send me files over email if you want. I'm very Googleable, so you can find my email very easily. But if you want to share them with everybody else, I think a link on the YouTube channel, on the comments in the channel is probably good. But we're working on Discord. Okay, so we're making that happen. Now, I have big news. If you remember from last week, I was telling you how I am not entirely comfortable with maintaining these live streams in my personal YouTube account for several reasons. One is that I want to make this, and I want to keep this doing for the foreseeable future, and I want to build up a repository of knowledge and a community around this project. And I don't want to make it exactly just about me. I want to make it about other people. I want to make it about the community. So that's why I thought perhaps moving all of this into a channel that has its own name and its own philosophy, its own ethos, would be a better idea. So, and it's also a much better platform for other people perhaps to jump in and start contributing like their own tutorials, their own work. So for that reason, I have an announcement to make, and it is that we're all going to be transitioning from my YouTube channel, Garcia del Castillo, to a new channel that I just started, which is going to be called Parametric Camp. Okay, so I'm going to drag this in here. As you can see, there's right now, which I'm going to drag here. So you can see right now there's absolutely nothing because I just made this decision a couple days ago, and and there's nobody, there's no followers, there's no anything. But the idea is that Parametric Camp is actually a project that I started like a long time ago with my brother Fernando, who might be on the chat or somewhere. And we used to do like physical workshops on parametric design, and we used to tour Europe, and we used to tour Spain, and we did a lot of workshops, and we taught a lot. And this was back in 2011 and 2010. And they were like physical workshops, so people would gather physically, and we would teach them. We had an amazing time. It was just I don't know. I thought it was great. And it was back in the times when Grasshopper was in its very early stages. I had recently moved to Boston. It was like very interesting times. So we already had. So I thought that extending this idea of like parametric design, computational design, and bringing it more to like a modern times. So this used to be physical workshops, but perhaps like taking this idea and bringing it now to a online community where we can perhaps like do a physical events, we can do online events. I don't know. There's like a lot of potential for a lot of things. So my brother and I were talking about this, and we decided to bring back this name. So if you go online, if you Google Parametric Camp, you will see a lot of the work that we did back in 2011 and 2012. You can even see that the website doesn't really work anymore. Um, but I do like Parametric Camp as a name, as in like, yeah, let's all gather and like spend like some intensity time like doing computational design, you know? So I'm going to, so what we're going to do is, we already have like Twitter, we have Instagram, we have everything, but we need to set it up yet, so it's not ready yet. So my plan is the following. What I'm going to do is we're going to transition over the course of a full month from my channel that has some community around, that has some of you already know me, there are subscriptions. We're going to transition slowly into the new channel. And for that, I'm going to ask you guys the favor of going to this channel and subscribing, because in order to get it working and have a name and have everything, we need at least 100 subscribers. So the sooner we get 100 subscribers here, the sooner we can start like pimping it up and making it more professional. And so I'm going to paste the link to the new channel here on the chat. So if you guys are nice enough, just please click there and click on subscribe and click on notifications, because we will be transitioning to this new channel very soon. Okay. What I plan on doing is I plan on maintaining the live streams from my channel, just because it has a bigger outreach right now. I plan on maintaining the live streams on my channel for the time being, at least 3 or 4 weeks. But I plan on the material that we're generating, the videos and the content, start dumping it already into the Parametric Camp. So the videos that we are chopping and that we're cutting, which we haven't published yet, will start being published here. And then at some point, I will start doing live streams from my YouTube channel and from this channel interchangeably until we fully transition to Parametric Camp. Okay. Um, so, and then the Discord channel will also be under this name. I already have the name reserved, I believe. We also have a GitHub page, so we're all ready to go. We just need the content. Also, you may have noticed that there's nothing in it and that the website doesn't work. So if any of you are savvy and graphic designers, if you like vector geometry and that kind of aesthetics, and you want to think of like a logo, a typography, like some background images, whatever, we are super open to contributions. So if you want to be the image of Parametric Camp, we would very much like to invite you to be part of it. Some people are saying that you can't subscribe. Okay, how about, can you try this second link instead? This one here. This one doesn't have the subscription prompt. Maybe you can try that second one. All right. All right, how are we doing? yeah, so I will talk perhaps a little more about the history of Parametric Camp at some point. Um, but yeah, so I see. All right, I can see already. uh, yeah, I don't know how many subscribers there are there. Switch account. Can I switch here? Uh, yeah. Can't see the button to subscribe. Oh, okay. So you can't subscribe. Second one doesn't work. Hmm. Okay, interesting. So maybe I have to verify the channel or something. Uh, okay. All right. Okay, I will. Yeah. What about? Um, let me bring that offline. Um, why is that not working? Huh. Well, that sucks. No subscription. You might have to make the channel available to the public. Huh. I thought it was available to the public. Uh, yeah, you're right. There's no subscribe button. Uh, huh. Is the channel public? So you guys can see. Yeah, there is a publicity checkbox somewhere. Yeah, do you guys know where that is? So, uh, your channels have not come up in search results. Yeah, I mean it's very new. So, Hariprasad. Okay, channels. It works now. So people are saying that it works. Um, now it's working. It works. I could subscribe now. Works now. Okay, I got a pop-up asking if I'm sure to subscribe to the channel, but otherwise there's no other button on my end. Working now. Okay. Yes, it works. 10 subscribers. Okay. So it looks like I can see 7 subscribers now. Yep. So, but all right. But you're right. I will definitely check out what's going on with that and see if it's Oh, I see 50 subscribers already. All right, working great. All right, thank you guys. Let's do this. Woo! Parametric Camp. Choo choo. Should I bring a hat and like a whistle and be like the mean coach, the mean camp coach? All right. Okay, so yeah, I see 55 subscribers already, so that's great. So maybe we can start the channel sooner than later. Anyway, okay, so as I was saying, if anybody wants to help with some graphic design for the channel, I'll be more than happy to to welcome contributions. Just reach out to me, Instagram, Twitter, email, whatever you fancy. Okay. Now let's get busy. It's already been half an hour. Okay. So what are we going to do today? What we're going to do today is we're going to learn. It's going to be like a basic tutorial. It's going to be a beginner's tutorial to the world of C# in Grasshopper. And what we're going to do is we're going to do that by mimicking the functionality of regular Grasshopper components with C# scripting. It's going to be a really good exercise. And this idea actually comes from a project that I've been working on with a group of my students in the past, which we have called Grasshopper Sharp. So GH Sharp. The idea is that we're currently working right now. We've been working for the past year. We're working on this collection of files where we can we have basically, so for example, if you go to surface analysis, you see that you have a lot of components here. So what we're doing is we're trying to take each one of those components. So for example, this original component, the original component, the original component, this one here, and then we are trying to mimic the functionality of each one of those components, but inside of a C# component. This is an educational project, so a lot of what we do is we want to make it very simple to understand how these things work. So we add a lot of comments and we explain why things are going the way they work. And the whole purpose is not to make Grasshopper open source or anything, but is to make people who are willing to go a bit farther than what's Grasshopper gives them out of the box, to make them learn how this functionality is implemented with code so that they can extend and they can improve their own functions and their own Grasshopper definitions with so it's like a step, it's like a transition project to help people go from vanilla Grasshopper to actually scripting their own stuff. So it is, as Bakari says, it's in a way a reverse engineering, but not for the sake of open sourcing or anything. It's purely an educational. It's purely an educational project. So what we're going to do today is that we are going to. I'm going to focus on simpler components. So I'm going to focus on addition, some vector component. Oh, I forgot to say this project is currently on the works right now. So we're working very actively on this right now, and well, not right now, but we were working on this a lot, and we will get back to this during the summer, hopefully, and we will hopefully publish an alpha version or a beta version sometime openly for everybody, so that you guys can download these files and you can check them out. We thought it would be an easier thing to do, but it's taking us a lot of time, and there's a lot of components that are not straightforward to deserialize. So we're working on it, okay? But sometime in the future, all of you guys will have this accessible to you. Now, how am I going to do that? I'm going to basically make a lot of tiny exercises where I drop a vanilla Grasshopper component, and then I'm going to write the same component in C#, and I'm going to explain. I'm going to be I'm going to be explaining a lot of the basics. So I would like to make this an introductory video more than an advanced one, perhaps. Yeah. Shall we just get into it? All right. Okay, so I'm going to close this here. And I'm going to have this here. And we can probably start. Are we good? Do I need anything? I probably want to save this file somewhere. So G# live, for example, I can be. And I think before we start, I'm gonna go and get some water. Can you guys give me a minute? I'll be right back. Just 1 minute. Thank you. Okay, I'm back. And I'm back with the. I've gotten really good feedback about this mug. You guys like it a lot. Okay, um, so let's get busy. Um, so where are we? We are here. Okay, so um, what I'm going to do is, as usual, hey Victor. Okay, yeah, that is a really good question. When I say vanilla Grasshopper components, um, when I say vanilla, I mean just components, just regular Grasshopper components. So the ones that you can find when you click on Grasshopper and when you just like drag and drop something here. And I mean that as opposed to, for example, C# scripting component, Python scripting components, which have code inside of them that you can write on your own. So that would be like a more advanced version of Grasshopper components, or libraries, or plugins that somebody else has contributed. Vanilla is a really common term in computer science when you want to refer to the functionality that comes with a programming language just out of the box, without using libraries or without using code that other people has contributed on top of that base programming language. Is that clear? Vanilla Grasshopper? Okay. Sorry, actually, yeah, that was an assumption. I never, yeah, that makes sense. That question makes a lot of sense. Okay, so as usual, I'm going to start by not doing the introduction and then just doing the introduction by the end. Can you guys hear me? Uh, Open widget. Can you guys hear me? I'm getting a message here that says that my audio is not right. Oh yeah, because I was probably because I stopped the audio. Okay, okay, right. Okay, so let's get started. What I'm going to do, I'm going to record the introduction later as usual, and then I'm just going. So the first component that I would like to do is going to be addition, because I mean hello world. Okay, so and then I'm just going to drop here a couple of sliders. Um, and I'm going to plug here a panel, and then we just get the addition. I mean, this is super simple. This will be a good way to just like talk a little bit about a C# component. How do you drop it? How do you rename inputs? And then how do you give the inputs some types? Okay. Because again, I want to make this an introductory, like a beginner's workshop. So I will be going over some of the basics of C# scripting in Grasshopper. Okay. So let's get to it. Oh, Remy, by the way, if you're around, we're going to try keyframe 1, if just for the sake of quality. We'll talk about that later. Okay. A good way to start this video is probably going to be with the simplest component that I can think of, which is the addition component. The addition component just takes in two values and then returns the simple sum of those two values. Okay, I would like to start with this one because I would like to go over the basics of how to deploy a C# script component, how to change the inputs, and how to make them work towards what you want. Okay, we're going to go to the basic script, C# script component. Oh, and I forgot, I'm going to drop a bifocals component here just for the sake of having much more feedback. And then you saw that I just dropped a C# component. The C# component, like any other component, has the inputs on the left and the outputs on the right. What's important when you start a C# script component is that you need to be very specific about which inputs this component is going to take. So two things that you would like to do is first, you're going to want to rename them. So you can right click on the parameter input and then rename it to a particular name. So for example, I'm going to do A because I want to really, really mimic this component. And here I'm going to right click and I'm going to type B. Okay. I can also do the same for the output. I can right click it and rename it to R as in result. And then And then the second thing, and this is super, super important, is that we need to figure out what kind of accessibility input these parameters are going to have and what kind of types they're going to accept. When I mean accessibility input, what I mean is whether if these components are going to work with each one of the elements that are passed individually, are going to work with them as a full list, or are going to work with them as a full data tree. What that means basically is that it doesn't mean that, for example, if I choose item, it doesn't mean that it will only be able to take one single element. What it means is that it will perform the operation that it will perform with each one of the items on the list. Okay, and this perhaps will be a bit more relevant as soon as I show the next component, which will take a list of data as an input. Okay, so for the time being, we're going to leave A and B both at the item access level so that they perform individual operations with each one of the elements that are passed to this component. Okay, so if I give them a list of 10 elements, it will add each one of them at a time. The other thing that I would like to do for each one of the inputs is to work, I will need to define what kind of type this input is going to take. And this is important because C# is a strongly typed language, which means that whenever you declare variables, which is what these inputs will become when in the functions that are inside of the component, whenever we declare variables, we need to tell C# what type of variables those are. Are those numbers? Are those text? Are those strings? Are those vectors? Are those circles? We need to specify it because C# needs to do some operations, like it needs to figure out exactly how much memory it needs to find, how much memory it needs to allocate. So it needs to do operations that rely on knowing what type of data it is. This might be a little painful, but it also has a lot of advantages in terms of, for example, performance and compilation error checks and all those kind of things. So because we are going to be adding two numbers, I'm going to go to type hint and I'm going to go to the top half, which is more or less the primitive values, and I can see that I'm going to click on double, which is the C# way of saying that this is a number that has double precision floating value. That is not correct. I think it's a double precision value, which means it's a number that has decimal part, but it also has a lot of precision, as opposed to, for example, floats, which are also have a decimal part, but they have a little less, they have half the precision basically. So I'm going to click on double here. I'm going to click on double for the other input B, and I'm not going to need to do item list or data tree access for the output, or I also don't need to specify the type of output, because that will be automatically defined inside of the component, and it will be, and Grasshopper will take care of that. So I'm going to plug in these two things here, these two inputs. I'm going to copy paste this panel here, and I'm going to now go in and start writing my code in the component. Okay. Okay. All right. So what is next? We are going to. Am I recording and everything? Yes. So I'm going to. Oh, I see. I see 60 subscribers already. Choo-hoo! I see. Okay, so what are we going to do now? We're just going to go in and do it. Okay. In order to modify the component and to start writing code, we're going to double click inside of the component here. And then what I'm going to see is this screen that has a lot of stuff, and I can actually expand and contract these like initial sections. We're not going to get into what any of this means today, but I just want to let you know that the important stuff is this function here. This is a C# function, which is the function that is executed every time this component needs to yield a solution from the inputs. And interestingly, you can see that the function is called runScript, which we don't really care about. But what we care about is that the inputs, so A as a double value, B as a double value, and R as an object that we output, those have been already set automatically by Grasshopper given the inputs and the things that we have set here from the interface. So if I were to change, for example, B to a list access of integers, right, we could see that B is not a double anymore, but it's a list of integers. So this we cannot change manually, we change it through the interface. Okay, I'm going to revert that. I'm going to go back to item and I'm going to go back to double. Okay, and so it is here. Here we write our awesome code. It is inside of here that we can write the code that is going to be running inside of this component. So what is it that we want to do? It's going to be super simple. We just want to take the two input values, A and B, and add them together. So a way that we can do that is, for example, I can declare, if we're going to add two numbers, the result is going to be also a number. And if the two numbers have decimal precision, the result is also going to have decimal precision. So I can declare a variable of the type double to contain the addition of these two values. So I can say, for example, double sum is going to be equal to the addition of A and B. So A plus B. Okay? And once we have that, I can run this code and you guys can see that it runs, there's no errors, etc. But I don't get any output here. This is important because we have made the calculation inside of the component, but we haven't really specified anywhere that that result should go out through the R component, okay? So through the R output. So that's why the last thing that we should do is here on the outputs, we should say the value of R is going to be equal to that number that I just calculated before. So sum. And as I do that, I now hit execute. And you can see that this value is being output by the component. I can change these two inputs and you can see that it works exactly the same. So it looks like we're good to go. You may ask, oh, but isn't this a little redundant? So are you doing a variable here and blah, blah, blah? So could we not have written just R equals A plus B? It is true. It is going to work the exact same way. I just find it a little cleaner to do it the other way, just because it's easier to read. And when the component is a bit more complicated, I just like to keep things separate. I like to keep all the calculations in one place and then just have the outputs at the very end and be like, this is what we need to churn out of the component. Okay, it's just a personal practice, it's style. And from a performance standpoint of view, yeah, you are creating a variable, but that doesn't really make that much of a difference anyway. So I like this. So I'm going to go for this as the addition component, and we're going to leave it here. I just want to point out one thing. The addition component doesn't only, the vanilla Grasshopper one doesn't only add numbers, but it can also add other things that are addable. Like, for example, it can add two vectors together. It can add complex numbers, I believe. So there's a lot of things that the component can do that we're not going to be fully replicating today because I want to keep this at an introductory level. Okay, so let's move on to the next one. Okay, so we got one in. How is this? Is this too slow, too fast, too good, too basic? I'm going to be building up in complexity, okay? So I wanted to spend a little bit of time in the script part of this one just to do a general overview, but I'm going to go a little faster now. Okay, so let's say now I'm going to create a list, and I'm going to have 0, 1, 2, 3, 4, and 5. No, I'm going to be 0, 10, 20, 30, and 40, for example. And it's going to be multi-line data. Okay, because the next component that I'm going to do is I'm going to do list item. I'm going to do the component that takes one element from a list. Audio still working great. Good. So, and that one is going to be list item, and here, and for example, element number 1. All right, and I'm going to put a toggle here for the wrapping. Yes, perfect. Move not too fast. For me, is too far, I think, but I give it a try. It looks different from the Mac version. We're not going to cover C# syntax yet. I'm going to assume some familiarity with C# syntax. I will do like a full playlist. I want to do like a really good full playlist on basic C# from scratch. So I will do that at some point in the future. Okay, so let's take a look at list item. I think this is a really good component to take a look at. Also from the how do you generate the list panel? Oh, that's a good question. Is that something that I should actually cover in the actual video? Let me do that in the actual video. You're right. That's probably something we wanna show. All right. The next component we're going to do is going to be the list item component. And if you are familiar with this component, what it does is it takes a list of data. So for example, here I have written a panel with 5 numbers. And for those of you who might be curious, what I've done is to make it real fast, I've basically dropped a panel by doing 2 forward slashes, which is the shortcut for a panel. And then here I have double clicked and I have typed 0, enter 10, 20, and enter, and 40. And then so that it becomes a list with multi-line data, I have right-clicked here and I have typed multi-line, so that now it is a list of numbers that I can feed into this component. Okay, so for the list item component, what it does is it takes a list of data, whatever data, it doesn't matter, and then you can choose with the index number, you can choose which element you want to cherry pick from this list. Okay, I would like to remind you that in computer science it's very common to start index numbers with 0. So the first element of a list is usually element number 0, and the last element of the list is usually however many elements are in that list minus 1. So if your list has 5 elements, then the last element is usually the one in position number 4, is item number 4. We can see that very clearly here on this list here. So the index is going to be the position of the element, and you can see that as I go beyond how many elements are in this list, the component gives me an error unless I toggle the wrap function, in which case then the component just wraps the index numbers and starts from the beginning again. So 5 becomes 0, 6 becomes 1, 7 becomes 2, etc., etc. You can also notice that if I toggle false and I go as farther than how many elements are in the list, I get this warning set saying supplied index is too high. We are going to mimic that functionality because it's very good practice to give your users to give feedback about what's going on your component. It's a very good UI practice. So because if you're doing C# components, you're probably doing something that is going to be used by yourself or by somebody else. So this kind of interfaces or these kind of tooltips are really good practice to do. So so let's do that. What I'm going to do is I'm going to drop here a C# script component. I'm going to change the inputs. So I'm going to say this is going to be the list. This is going to be I, which is the index number, and I'm going to zoom in so that I get these buttons prompting me to add more inputs. So I'm going to add another input here that I'm going to call capital W. All right, and then for the output, I'm going to choose I, but that is actually not great practice because internally I would have two things, the input and the output of the component with the same name, which is going to be confusing for the component. So what I'm going to choose is, I'm not going to be able to do exactly the same name. I'm just going to choose to give the output this name, iout. Okay. Now, I'm going to plug in here the same stuff. So, I'm going to give these things types. So for wrap, it's going to be a Boolean, which means something that can be true or false. For I, which is the index number, I'm going to use an integer because I don't want decimal numbers here. And for list, this is going to be special because since this component can work with any kind of data, I don't want to bound this functionality to just numbers or geometry. I want to make it as generic as possible. And in order to do that, I'm going to choose the most generic type of object that exists in C#, which is the system object. So this is basically, imagine the system object as like the father of all data types and all types of variables in of something like that. Okay, it's the most general type of data that you can find in C# component. It's the one that all data types inherit from. And also very important, I have left item access for W and for I, but for L, because for this one particular component, I do not want to look at each one of the elements in particular, but I want to look at the list as a whole, so that I can cherry pick from each one of them. It is important that we switch from item access to list access, so that when we are inside of the component, instead of having access to only one element of the list 5 times, I want to have access to all the 5 elements all together with a list. Okay, this is very important for this one. I'm going to zoom in a little bit here, and then you can see that my inputs are L, which is a list of system objects, and then I, which is an integer, and a Boolean value for W. Okay, so I think we're good to go. So we can start like getting our code ready here. All right, great. Okay, Arasto is asking why not remove out. I like having out because I like seeing error messages which come from the output. That is very useful when debugging. I may actually talk about that in the video. Chandra is asking me to ask Long to join us. Are you cheating on me with Long, Chandra? Long is actually a really good friend, and yes, you are right. He's very good at C# and he's very good with these things, and he has a lot of really good content out there. So if you guys are interested, you should definitely check his videos out. Salvador, list access works like graph in vanilla. Actually, yes. That is actually a pretty. No, so item access works like graphed in vanilla Grasshopper. So when you graph something, you basically create a tree with one element, and then the component takes each one of those elements. So item access is the one that would work like graphed. I've noticed that removing the out component makes the script component stop working, but I don't know why. I have seen it in my Python script. I am not sure why that is. I don't know if that makes it stop working. I don't think it does stop it working here. Maybe it's a Python thing. I don't know. You know, I'm not a huge fan of Python anyway, so I'm joking. Okay. Okay. So let's get ready for this. Okay. Great. The first thing we're going to do is we're going to implement just simply taking the one element that we need from the list, and then in a second step we will implement the checking. So make sure that there are enough elements to pick that index number, and we will then implement like the wrapping functionality. So let's get to it. The first thing that we're going to do is very simple. We're going to say I want to declare an object that is the greatest type here. For example, datum, which is going to be, and then we're going to choose from the list that is coming in, we're going to choose the element that is in position I. So very easily we can just say from the element, from the list, I want to pick the element at position I, and I can use the square bracket notation to point to one particular element within the list. Okay? Now what I can do is for I out, I can output that datum component, that datum variable that I just created. Okay? So let's see if that works. Right now it doesn't work because I don't have anything connected here. So let me plug in here this and this and this, and then something else that and you can notice, you can see that if I click here, it's giving me an error. Index was out of range. And this error is because I'm trying to fetch element on position number 7, which doesn't exist in list. And in my code, I am not managing correctly that situation, so the component is giving me an error. One reason why I like keeping the out component, the output of the component, is because I can get, if I plug in a panel, I can see those errors textually on the screen rather than having to hover over the, or clicking over the balloon. So that's one of the reasons why I typically keep the out component. Yeah. So first things first, that is a really good proof that we need to apply sanity and we need to do checks on our code. But let's first see if it works at a basic level. So if I say 4, I'm getting 4, 32, 10. So that looks like it's working. So it looks like at a basic level, the component is doing what it should be doing. So that's great. So now let's implement here some kind of error checking to make sure that that we are fetching the element in the right position. So how am I going to do that? I'm going to create first a variable that I'm going to name position, which I'm going to initialize to the value of I. So what I'm saying is, you're giving me the index number, I'm going to keep it in this variable, but then I'm going to check if this number that you're giving me is correct. So for example, I'm going to say, if position is greater than, is greater or equal than the number of elements that the list has, then this is probably not good because you are asking for a number, a value that is outside the range of this list. So typically what you would do is that you would throw an error message here. So we can do that by saying component dot add runtime message and then Grasshopper runtime message level dot warning index is out of range, for example. And then here, because we don't want to keep working with this component, we want to stop the functionality. We don't want to hit this line of code, which would give me an error. What I'm going to do is I'm going to type return. Return will immediately finish the execution of the component and not continue with the code. I'm going to run this. Everything looks good here, but as you can see, as I move farther up, when I hit 5, now I'm getting this error warning message that I have here. Index is out of range, which is similar to supplied index is too high. Maybe I can, if I really supply index is too high, I'm going to run this and you can see that the error message now is exactly the same, is matching, all right? And you can see that there's no output. I'm not giving anything and there's no error. So this is a much cleaner solution. It incorporates checks, so that is great. But if you can see in the original component, if I click true, now it's doing the wrapping functionality. Okay, so it's doing, it's figuring out a new position to pick it up. So that's probably something that I want to implement here as well. So I'm going to I'm going to keep this true. And then what I want to do here is, okay, so inside of this check, if the index number is too far out, then I want to do two things. If wrapping is true, I want to calculate which one is the new position that I would fetch, but if wrapping is false, I want to do what I've been doing, which is just giving this error message. Okay, so I'm going to write a conditional here. If wrapping equals true, or you can shortcut this by just keeping the if wrapping, then do something. We will figure that out. Otherwise, if it is false, then do give this warning and stop executing the component, just like as we did, right? So this works. So now it's still working well when wrapping is false, but when wrapping is true, I still hit the error because I'm doing nothing here and the component keeps executing. So now I want to do something here to make sure that if wrapping is true, I choose a right value for the position, which I'm going to substitute here, okay? And how is that going to be? For this, I'm going to use the modulo operator. The modulo operator is an operator that gives me the remainder of an integer division with a number. What does that mean? It means that, for example, should I do, yes, let's do. So for example, the modulo operator is this guy. It's a percentage sign. And what it does is it tells me, it does an integer division, and it tells me how many elements are remaining in that division. So for example, if I divide 6 by 2, okay, 6 by 2, the result is 3. And what is the remainder? Nothing. Okay, if I do 7 divided by 2, and it's an integer division, so no precision, no decimal values, the result is still 3, but I have 1 unit that is remaining. No? If I do 8 divided by 2, the result is still 3, but I have 2 units that are remaining from this division. So that is exactly what the modulo operator does. So, so if I say, for example, 6 modulo operator 3, what am I doing here? Yes, modulo operator 3, the result of this operation is 0. So the remainder of the division is 0. If I say 7 modulo 3, the remainder of dividing 7 by 3 is 1. If I say 8 modulo 3, the remainder is 2. And if I say 9 modulo 3, the remainder is 0 again. This is very useful because if we say, I have elements in position 0, 1, 2, 3, and 4. But if I reach element 5, I want the result to be 0. So we can achieve that with the modulo operator. So how are we going to do that? If this is true, then the variable that I've defined as position, so post, is going to be equal to the value that you're giving me modulo the length of the list. So L.count. And if I do that, you can see now that we are getting, so we are at 4, and as we switch to 5, we go back to 0, and as we switch to 6, we go back to 1, 2, 3, 4, 5, 0, etc. And if we turn this off, we get the warning message that we have been discussing. All right, so it looks like this is ready to go, and it mimics pretty well the original component. Okay, so we got it. That was list item. Okay. All right, what is next? What am I doing? Oh, we're doing series. I have some notes here that I wrote yesterday. We're doing series of numbers. So we're gonna mimic the series component. Could we set default value for I in the C#? I think because it's an integer, it already. That's actually a good question. I don't think. Well, you can set it here. You can set it here. So you can say this is going to be the default value is going to be 1. This is going to be an integer, and then here, for example, you say a is going to be whatever is coming from x, and you can see that a is already 1. So you can hard code it here as part of the item, but then if you override that with an actual value, then you will be overriding that. Yeah, so you basically set up default values by just like adding them here as part of the component. All right. Okay, so what is next? We're going to do series of numbers. So numerical series, where is that? Sequences here. Series, and then for series, we have like first number in the series is going to be, yeah, whatever, 0. And then N and Z. Okay, and then here, so step is going to be 2 and is going to be 10 values or 4 values. I don't know, whatever. Okay. Yes, 7 values. Okay, so this component takes an initial value. It takes how many elements we want to output in the series and what is the difference between them. Okay, I'm going to make this negative because I want to make sure that we have that possibility of negative values. Okay. Okay. So yeah. So let's start with this. The next component we're going to work with is going to be the series component, which is a very interesting component. It just takes a starting value. It takes how many elements I want to generate in this series, and it takes the step size between those elements. And what it gives you out is a list of the numbers that start with this initial value, that many values, and the difference between them. This is a really good exercise because we can train for loops with this component in a very programmatic way. So let's start doing it. I'm going to write a C# component here. I'm going to rename the input, so that's going to be S, that's going to be N, and then I'm going to add a new one that is going to be called capital C, and then the output is going to be S out. Okay, I'm going to plug in a panel here, and then I'm going to plug in these guys. And remember, we always need to change the input types and the input access. Because for this one, I'm going to be outputting, I'm going to be taking single elements. I'm going to keep these item accesses as items. I'm going to keep the access of the inputs as items, not as list or data trees. But I will need to change the types. So for S is going to be the starting value. This can be any number with or without decimal part. So I'm going to choose double. For N, which is the step size, this can also be. So for that, I'm going to choose an integer type. Okay? And then I'm going to go in here. I'm going to zoom in a little bit. And then we're going to write a for loop that is going to create, it's going to populate a list with elements that are going to be output by this component. Okay, should I do a list or should I do an array? Both work equally fine. C# is very list friendly, so perhaps I'm going to go for that. I think I explained arrays in the Game of Life stream so far, so yeah, I'm just going to go with lists. It's a little, maybe I can do both. Maybe it's not a crazy thing to do both. Okay, so let's do this. Because what I want to output is going to be a list of data. The first thing that I need to do is I need to declare that list before starting to populate it with the values that I want to create. For this, I have two options. I could do, for example, an array of double values or a list of double values. I will talk in some other workshop between the difference. I will talk in detail between the difference between arrays and lists. But long story short, arrays give you better performance if you know how many elements you're going to be storing and if that is not going to change over the course of your computation. Whereas lists are much more flexible, so you can add, remove elements, and they can expand, they can contract at the expense of like a tiny bit of more computational time. Okay, but at this level it's not very important. So perhaps I'm going to start with a list, and then maybe we can also just real quick just implement the same thing with an array. It doesn't really matter for this example, because I know as part of my inputs, I know how many elements the list is going to have. So I know I can use that for creating an empty array and populating it. So let's start by creating a list of values. So that's going to be list. I open angle brackets to define that the type that this list is going to hold is going to be doubles, so numbers with repetition value. And I'm going to call this nums. And I'm going to initialize this as an empty list by saying new list, then angle brackets. I'm going to type the type again, double. I'm going to close angle brackets, and I'm going to open and close parentheses to indicate that this is an initialization, that I want to start an empty array, an empty list. Okay. Now, the next thing that I'm going to do is I'm going to use a for loop to go over all the elements that I need to generate, compute each one of them, and then add it to the list. So I'm going to open a for loop where I'm going to say, I'm going to create a value called I, which is going to start at the number 0, which is going to be less than how many elements I'm going to create, and which is going to increase by 1 in each loop of the for loop. I have not recorded a full list of C#. Let's learn how to program in C#, but I will hopefully do that sometime soon. So check back on the channel about for loops and how these are done. Okay. And then the next thing that I'm going to do is I'm going to say, well, for each one of those values, I'm going to compute which value I should output from the list. So that is going to be double val, for example, or v, is going to be a number that I need to calculate. The rule here is that the starting value is s, all right? And then the step size between each one of the numbers is n, okay? What that means is that if I have a for loop here that goes from 0 to 5, 7, 9, 100 elements, it means that each one of the elements on the list is going to be equal to the starting value, so 5, the base value, plus how many elements I have generated times the step size between those elements. So you can see that the first value is 5 plus 1 time 0.007. You can see that the value of 6, the second element, is 5 plus 2 times 0.5. So here we can say the value of each one of these numbers is the value of the base value, so that's s, plus how many times, plus the step size, which is s, times how many elements, so the number of this element within the list. So times I. And then once I have computed that value, I can say nums.add this value to the list. Let me see if anything is working. Well, something is not working. Yes, I have a typo here. This should be a parenthesis, not a square bracket. And as I run this, something is not working also. The error is that blah, blah, some invalid arguments. What am I doing here? Can I convert from list double to double? All right, I'm going to pause here. I don't know what's going on here. Do I have the right? Oh, yeah, because n is double and c is int. Adding berms into nums. All right, guys, what am I doing here? s plus n times I. Nums add, oh, yeah, because I'm adding, I'm adding the list to the list. All right, you see, this is what happens when you stop drinking caffeine. Oh, yeah, I've been trying not to drink caffeine for 2 months, or three. It's already been 3 months. I don't know. It feels like so long. Yeah. So yeah. So you lose a little bit of focus. I'm regaining it slowly, thankfully. Yes. So let's get back to recording. Yeah. Sorry for that. I just realized that I was doing something very stupid. I was adding the list inside of the list, which makes no sense whatsoever. So it was just a typo. I need to add the value that I just calculated to the list of numbers. Okay, and as I do that, this works fine. I still don't get the result because I need to specify that S out, the output of the component, needs to be equal to that list that I just generated. Okay, so I'm going to click execute, and you can see that this looks like it's working fine. So I get more or less elements. I get more or less step size between them, or I can shift the this. I don't know why this is an integer. This should definitely have decimal part. All right, but it looks like they work pretty well. All right, so that's great. Let me just real quick do the same thing with an array, just for the sake of illustrating this. I'm going to comment all of this out, just to keep it here as part of the doing it with the list. But now here, very similarly, I can just say I'm going to create an array of nums, which is going to be a new double array, which is going to contain C elements. C is the number of elements that I'm going to add to this array. And then here, I'm just going to copy paste the for loop, and I'm going to say double value is the same thing. Okay, and then here in nums, and then in position number I want to store the value of val. And then as I do that, the component works exactly the same, and yeah, it works well. Okay, so that was number series. I think this was a really good exercise to do for loops. It's so good that I actually want to do another one, which also involves for loops, which is going to be numerical ranges. Okay, let's do that real quick. Okay. All right, this is going well. Okay, so numerical ranges. This one here, create a range of numbers. The domain is going to be the domain of a numeric angle, number of steps. So number of steps, I'm going to copy this here. And then the domain, I'm going to create here something that goes from, I don't know, from 1 to 3 in 5 steps. So I'm going to construct a domain. Construct domain here, and I'm going to use that domain here as the range that I want to divide, and then this is going to be okay. So this is good practice because domains are also very common and very popular in Grasshopper. So we want to take a look at this. All right, how are you guys doing? Are you guys doing good? Oh my God, we have so much to cover that we haven't yet. Okay. All right, so let's do that. Let's do this a bit faster because I want to cover more stuff. Okay. So let's do it. I have created here a range of numbers by first constructing a domain. A domain is an interval between two numbers, and then specifying with the range in how many divisions I want to chop this domain. Okay. So how am I going to do that? As usual, I'm going to drop a C# component here. The input is going to be D. Then this input is going to be N, and then the output is going to be R. And then for the input types, I'm going to do the following. N is going to be an integer of access type item, just because I want to chop something in whole numbers, not with decimal part, so integer. But for domain, I'm going to choose here the data type interval, because for some reason, domain is how things are called in Grasshopper, but interval is how domain ranges are called inside of RhinoCommon. So I'm going to type here interval. I'm going to place this here, and then now I can start. I can start typing here my code. The first thing that I would like to do is, if I have a domain, so something that goes between two values, in this case 1 and 3, and I want to divide it in 5 segments, what I need to do is I need to first find out what is the size of each one of those segments, so that I can then create a for loop to go from the first number and then iterate. Okay, so what does that look like? I'm going to say, for example, double step is going to be equal to the how long, so what is the length of this interval, divided by how many times I want to chop this interval on. So I can say d dot length, and you can see that what this is giving me is the signed length of this domain. So in this case, it's going to be 2, positive 2. And the interesting part is that if this domain went from 3 to 1, then the signed length would be -2, which is very good also for calculating the step. So I'm going to choose length, and I'm going to divide this by how many steps I actually want within this domain. Just for the sake of making sure that things are going well, I'm going to print something to the output of my component. So I'm going to print step size plus and the number of step. I'm going to do that. I'm going to plug here a panel, and then it looks like step size is 0.4, which looks correct according to what I had before. So this is looking good so far. I'm going to now then write a for loop that starts very similar to what I did before. Starts with the base value, which is going to be the first number of the domain, and then starts adding based on how many elements do I have. So I'm going to create a list of doubles, for example, which is going to be nums new list double. Yeah, this happens a lot. List double. Okay, and then I'm going to write a for loop that is going to start at I0. I is going to be less than n, but at this time, this is something important to notice. If I'm going to divide a domain in 5 segments, then the result is going to be 6 values. Can you see that here? Because we're also incorporating the both ends of the domain. So in this case, I don't want to be less than n. I want to be less or equal than n and I++. And then, very simple, just like I did before, I'm going to create a variable called value. This value is going to be equal to the base value, which is going to be d dot t0, which is no, is t0 or is it start? No, it's t0, which is the initial value of the domain plus the step size times how far off we are on this list. Then nums equals nums dot add value, and then the output is going to be r, is going to be the values of nums. I'm going to click that, and I had a typo somewhere here. All right, I'm going to fix that typo, and as I do that, I'm going to switch here, and I can see that I get these numbers, and that if I change the step size, I get more or less elements, and that if I switch these guys around and make the starting point higher than the ending point, I still get the right range in the good sequential order. All right, so this is great. Another one implemented. Okay. How are you guys doing? You still there? Is this useful? Is this demystifying? Is this demystifying Grasshopper a little bit? Is it making it more accessible? Okay. So I think it's time to. I think it's a good time to start doing some geometry, and like move on from plain numbers. Okay. So we're going to do points, vectors, and lines. How does that sound? Let's get to it. And we're going to construct a point. We're going to construct a point out of three components. And these are all going to be here. 0, 0, 0. Up, Okay. Not catching up, but still awesome. Well, I mean, this is if you have not written code, or if you haven't really learned how to program, this might be a little too much. But it's still, I think it's still like easy enough to like be able to be something that you can follow through. But again, I will do at some point a full like let's start from scratch with C#, and then it'll make understanding this much easier. Okay. Vacaris, you got to do some homework. I mean, yeah, it takes some time to learn, man. Okay. Grasshopper 3D pilot. Thank you very much. All right. Construct point. Yes. Construct point here. Okay, and we have the point there. That looks good to me. Okay. All right, so more. Let's do more. Great. So enough with numbers. I think it's time to move on to some geometry, right? That's why we're all here. So let's start with the simplest kind of geometry that I can think of, which is a point. Okay. I'm going to mimic the construct point component, which takes 3 numbers, and then it just gives you this point in x, y, z coordinates on the viewport. Okay, that then you can manipulate and work with. So very simple. Let's start with the C# component. We have like, I'm going to uppercase this x, I'm going to uppercase this, I'm going to uppercase this y, and I'm going to uppercase z, and I'm going to say that all of these guys must be doubles. Okay. So right click, double, because they can be numbers and with decimal part, and the output is going to be pt. Okay. I'm going to plug this in here, and I'm going to go in, and I'm going to double click, and I'm going to start writing my code here. But before we do that, I would like to make a really quick comment. We're going to start working with geometry, and geometry is not anymore part of what comes out of the box with C#, with the plain programming language. All the geometry goodness that we have inside of Grasshopper is thanks to this thing that is called the RhinoCommon. And RhinoCommon is basically a library of geometry objects that lives on top of the C# programming language that is running under the hood in Rhino and in Grasshopper. So a lot of what I'm going to be showing today, if you Google RhinoCommon and you go to the RhinoCommon API, a lot of what I'm going to be showing today, in terms of geometry, doesn't belong anymore to vanilla C#. It belongs to the RhinoCommon library that is inside of it, and most of it is actually inside of rhino.geometry. And you can see how here we have Angular, dimensions, curves, B-reps, we have hatches, we have meshes, we have matrices, we have NURBS curves, we have a lot of really good stuff. This is what makes Rhino and Grasshopper so powerful, okay? So we're going to be using this API, we're going to be using this application programming interface because this is the power that Grasshopper is giving us. And we know that because you can see that as I extend the C# scripting component at the beginning, you can see that it's using all these native libraries, but it's also using all these libraries that come with Rhino and with Grasshopper, which is a very interesting thing. If you want to learn more about RhinoCommon, I do have here on my Harvard playlist, I do have a video somewhere where I actually go over RhinoCommon and I talk about the different types and I talk about how to read the documentation. So if you want to learn a bit more, feel free to go and check this resource. Okay? Now enough with the self-promotion. So how are we going to do this? Well, it's going to be super easy. The first thing that I'm going to do is I'm going to declare a variable, but now this time it's not going to be a number or a boolean or a list. It's going to be an actual point object. I'm going to declare a variable of the type point3d, which doesn't really stand for 3 dimensions. It stands for 3 doubles, which I'm going to call p. And I'm going to initialize, I'm going to create a new object by using the constructor syntax, which is new. And you can see that I already got an autocomplete that says point3d. And as I do that, I open parentheses and it gives me all the options. So if I tap with the arrow keys up and down, it gives me all the options of things that I can use to create a new point. So 3 doubles, a vector, another point, etc. So because I have the 3 components, I would like to use those. So I'm going to use X, capital Y, and capital C. And then on the output, PT is going to be equal to this new point that I just generated. Okay? As I do this, I'm going to turn this off so that you know for sure that this is the one that I'm creating. Because it goes green, you can see that the components are the same. And this point here is now a point that I could plug into any other component down the road. Okay? Which we're going to do right now because I'm going to extend this block to also deconstruct the point. Okay? Stay here with me. Okay, deconstruct point. I'm going to do this. I'm going to plug this in here, and then I'm going to plug this X here, Y, and Z, and then here I'm going to list a C# component. This is going to be P, right? And the outputs are going to be X, Y, and Z. And then I'm going to plug these things in here, these panels. Yes. Okay. Okay, let's go. So what I have done here is I have taken the construct point and I have attached afterwards down the road. I have implemented the exact same. Let me start over again. That. Let me drink some water. Okay, we're starting over again. What you see here, what I have written right now is I have added down the road after construct point, I have added a component that is called deconstruct, which does the exact opposite operation. It takes a point and it outputs the 3 components of that, the X and Y and C component of that point. So I have created also a C# script component that I have changed the input and output names. And on the input, I'm going to right click and I'm going to choose the right input data type for this P parameter. In this case, it's not going to be booleans or point or doubles anymore. It's going to be geometry objects, like for example, point3D. And then I'm going to plug this in here. And as I double click, you can see that I have a point 3D object as the input and 3 XYZ coordinates that are the outputs. Okay. What's interesting about this is that classes and structs, which is what point 3Ds are more complex objects than just simple numbers or simple booleans. And you can think of them as buckets that have information inside of them, information that has names attached to it. So for example, if I say, I want to take a look at the element P, the point P, and see what's inside, I can use the dot notation, and then this, I can use the dot notation, and you can see that this pop-up window will show me, for example, all these purple boxes are the functionality, the methods, the functions that are inside a point. So I can compute the distance to something, I can compare it to something, I can interpolate with other points. And the properties that has this wrench symbol, those are values of some kind. So for example, is this point valid, or is it coming from a faulty operation? Or for example, and this is the important ones, the X, Y, and Z values of this point. So these are the things that I would like to output as part of this component. So for example, what I can do is I can say the capital X, which is this object here, the output, is going to be equal to the property capital X of point capital P. The fact that they're both called uppercase X is just coincidental. It doesn't really mean anything. They could be called whatever else. But it's important that is a very important distinction to make. So the output of this component Y is going to be equal to the property Y of the point, and the output of this component Z is going to be equal to the property of this point Z. And as I do that, this works well, and I can change my inputs, and everything works as expected again. Okay. So yeah, so that is the basics of creating basic geometry objects and deconstructing those geometry objects to fetch their parameters. Okay, let's take a look at some more of this. Yes, that vacaries, that is typically sometimes referred to as attributes. Although if you're a pure C# person, attributes are actually a different thing. So the most common name to refer to those wrenches are either properties or fields, with the difference between those two being like super subtle, and we don't really need to get into that today. Okay, so what else am I doing? Oh, we're doing vectors. Of course we're doing vectors. Vector length. Okay, so I'm going to take this guy and I'm going to create a vector from XYZ coordinates, and then vector length. Okay. All right. I'm gonna have to cut it earlier than I thought because I need to go at noon. I have meetings all afternoon again. So where are we standing? I think I'm just gonna do vectors, create interpolated curve. I think I'm just gonna do vectors and lines, and I think I'm gonna call it a day there. Because I don't. Can I do recording this afternoon? I don't think that I can. So maybe we can continue with this next week, or I can do like a midweek stream maybe. I don't know. We'll see about that. I'll think about that because I also want to do some Q&A with you guys. So let's do vectors. Let's finish the line, and then we see where we are. Okay? Because I have a lot of meetings this afternoon. Okay, vector length. Yes. So okay. Another thing that I would like to do, for example, is I want to take a look at vectors. And for those of you who know me a little bit already, vectors are one of my favorite things in computational geometry, and they're extremely useful for so many reasons. So much that some of my friends actually call me Dr. Vector. So, but I don't wanna give that too much publicity. So, let's take a look at how to work with vectors, and let's do like a few components that work with them. The first one being we're going to take a vector and we're going to find its length. So how are we going to do that? Very simple. C# component. This is the v input, which is a vector. So I'm going to right click and say that it has to be the vector 3D type, and then the output is going to be L. Okay. And I'm going to plug this in here, and then I'm going to paste here a couple of panels, and then let's write some code here. So if you guys are familiar with vector geometry, I'm actually going to go back to the Harvard playlist, and I'm going to, if you guys want to refresh a little bit of your vector algebra, I do have a full list here where I go over vectors, vector properties, how to compute the length of a vector, how to do dot products, how to do cross product, and the geometrical meaning that all these operations have. So also feel free to check it out. I think it might be useful. So if you guys are familiar with vector algebra, to compute the length of a vector, what you do is you do the square root of the sum of the square values of each one of those properties. So there are two ways to do that here in the Grasshopper world. One is to do it manually, so to actually write the equation that computes the length of a vector, or to use the API in RhinoCommon. So I'm going to do both because I want to show the difference. The first one would be just writing it manually. It will be a value of the type double because it has decimal part. And what I'm going to do is remember, I'm going to vector length. Remember that the length of a vector is the square root. Where is this? Well, this looks terrible. Okay, images, what is the formula? Here. So for 3D, the length of a vector is the square root of each one of its coordinates squared. Okay? So how are we going to do that? First, we're going to add them. We're going to add them together. So that's going to be Vx multiplied by itself plus Vy multiplied by itself, so the y property of the vector, plus Vz times Vz. So what you've seen here is that I've taken each one of these values and multiplied it by itself. I could have done, I think there is a function called math square. No, there's math power, where you can elevate one number to the exponent. So we could have done this for each one of those values, but it takes a little bit more computational time and it has to call the functions. This is much faster. But remember that we need to do the square root of that value. So for that, what I'm going to do is I'm going to say math dot square root, and then I'm going to open parentheses and I'm going to compute the square root of this whole thing that I just cranked. And then the output is going to be L equals length. I'm going to output this, and you can see that the values match. So it looks like I got my vector algebra correct. Good stuff. The other thing that I would like to show you is that one of the nice things about working with a geometry API is that a lot of these operations are usually found very commonly within the API. So it turns out that, for example, the vector class, so this guy, does have all these properties, X, Y, Z, etc. But it also has a lot of goodies to doing common operations, like for example, finding the length of a vector. So something that I could have done instead, I could have said double len, but instead of computing this manually, I could have used the vector object and look at all these properties. So you can see it has like all this stuff here, X, Y, Z, unitize, square length, whatever. And one of the properties that it has is length, which gives me the magnitude of this object. So I can just access this property and I would get the exact same value, but instead of doing it by hand manually, I do it with the RhinoCommon API. Okay, but it gives me the exact same result. Okay, wonderful. Let's do a little bit more of vector algebra, which I think is really cool. Let's do dot products and let's do cross products. All right. Okay. So one vector, another vector. This one is going to be whatever, blah, blah, blah. And then I'm going to do the dot product of two vectors. I know, sorry, this thing here. And then this has a toggle to unitize, Boolean toggle, unitize the result, unitize the inputs, no? Unitize the inputs, yes. Okay, and then C sharp, A, B, U, and the output is going to be dim, vector, vector, Boolean, and I'm going to do the types. I'm going to do those on the video. So this goes here. Okay. Which one is faster? Kaved, which one is faster? Honestly, in this particular case, I'm not entirely sure. My bet would be that doing it manually is a tiny bit faster, because probably when I call the length property of the vector, what I'm doing is just I'm calling a function that is doing the exact same operation that I did manually. So basically, like by doing it manually myself, I'm saving myself like one tiny bit of like the program going from one function to the other, which takes like nanoseconds, but I think it's how it works. But I'm not entirely sure about that. Okay, so dot product. Great. What I have done here to start with the dot product is that I have created two vectors, and then I am using the dot product component to multiply them together. And if you remember, the vector dot product, if you remember, the dot product of two vectors is an operation that gives us a number in return. It doesn't give us a vector, it gives us a number. It's basically, the operation is basically the multiplication of each one of the components one by one. Again, if you want to hear more about this, this is actually the vector, this is actually the dot product that I'm showing right now on the video. And if you want to hear more about what the meaning of the dot product, for example, which is very useful to compute angles between vectors, check my video there. And what I've done is I have a C# component. I have already written all the inputs and the outputs, and then each one of the inputs I'm going to choose the right type for them. So A is going to be a vector 3D, B is going to be a vector 3D, and U is an input that tells me whether if I want to unitize the vectors before multiplying them together. So this is a true or false statement, so it will be a Boolean value. Okay, so let's go here. And again, I can do this in two different ways. I can do it the RhinoCommon way, or I can do it the manual way. I'm very much of a manual person, so I like teaching things low level so that you know how things work internally, and then you can do whatever you want in your life afterwards. So so I'm going to do it both ways. The first thing that I'm going to do product, and I'm going to do that by saying a dot. I basically need to multiply each one of the x and y c components of the two vectors and then add those results together. So that is the meaning, that is the algebra behind the dot product. So a dot x times b dot x plus a dot y times b dot y plus a times c dot b times c. If you guys were in my Harvard course, you would actually do this for homework. I have a homework which is just like replicate a ton of like vector endpoints and algebra components. And then d is going to be equal to dot, which is the dot product that we just calculated. As we do that, you can see that this is working, right? Except when I unitize these things. Unitizing means taking a vector and scaling it down so that the length of that vector becomes 1. Right now, I have no idea how long these vectors are, but they're probably not 1 unit long. So there are two ways to do this as well. Unitizing a vector is equal to taking that vector and dividing each one of its components by the length of the vector. We can do that manually, or we can use RhinoCommon's API. For this one, which is much faster, I'm just going to use the RhinoCommon API. So what I'm going to do is if u equals true, or this, which is the same shortcut, what I would like to do is before performing any operations with the dot product, I would like to unitize this vector, the vector a, and I would also like to unitize vector b, so that when they reach this point, they are vectors that are 1 unit long. As I do this, I'm going to now hit true, and you can see that vectors have been unitized and the result is consistent with the original component. Okay? The last thing that I would like to do is I would like to show you guys how to do dot product natively with RhinoCommon. It's also very easy, so you can just say a times b, and this this may sound crazy, but this kind of syntax also comes from RhinoCommon, from the fact that you can multiply directly two vectors, and because multiplying two vectors, the meaning is the actual dot product. So if I do that, I got my dot product value, and I am uncertain whether if there's like a third way of doing this, which might be vector 3d dot multiply. Yes, there is. But this is this is two vectors. So this would be a third way of doing it, which would be double dot, and this would be taking the vector 3D class and looking at the multiply static function, and then seeing that you can multiply two vectors together, returning the dot product. You can actually see that from the documentation. So I can multiply a and b, and the result will be exactly the same. So there you go. This is the dot product. Cool. Now cross product. Here, here, and then the cross product is going to be this guy and this guy, and also unitizing it or not. And then I'm just going to copy paste this one. I'm going to change this. I'm going to rename. I'm going to delete everything here. and yeah. Okay. How are you guys doing? Holding on? Vectors? How awesome are vectors? Mm-hmm. Vectors are what pros use in the real world. Keep this in mind. Vectors, pro stuff. So, cross product. Let's do this. Let's get on with the cross products now. So, I have added to what I just did before. I have added a new component, which is the cross product, and I have added its same C# script, and with the names, with the inputs and the outputs, and with the right types for the A, B, and U inputs. If you would like to know more about what the cross product means, it's actually a really interesting operation, because what it gives you is is the multiplication of two vectors, but instead of giving you a value, what it gives you is a third vector that is perpendicular to both of them. So and it's the result of doing a determinant operation on a matrix of those two. This is the formulation here, and I think I have an animation somewhere here that gives us like a visual. Yes, here it gives us like an interactive. So this would be the result. The blue arrow is the result of the vector multiplication of these two. You can see that it's always going to be a perpendicular vector to the plane in which those two vectors are oriented. The cross product is one of the most common operations in vector algebra, especially in computer graphics. It's really, really important that you guys understand it. The length is also proportional to the angle at which those two vectors are. So let's do it then. So here I got vector A, vector B, and remember, the result of this operation is not a number anymore, it's an actual vector. So I can do this, I can do vector 3D is going to be, and I'm going to call this cross, and I can say, for example, I can use the RhinoCommon API vector 3D dot cross product, and then I can open, and be A is going to be the first vector, B is going to be the second vector, and then the result is going to be cross. As I do that, you guys get to see. Oh, I forgot to actually replace this. This is not the cross. This is not this is not, wait, I am not doing this correctly. I had not, yes, so this is the vector, and L is the length of the output of the vector. So let me redo that. This is not great. V is cross, all right, and L is is the length of that vector. So let's see if this works. Okay, so sorry, this should be cross. Yes. Okay, so you can see that I'm getting the two vectors, the two outcomes are the same. If you, because we have to implement the unitize part as well, we can do the similarly as before. If it's true, then take A and unitize it, then take B and unitize it, and then after that perform the operation. Okay. We could write this manually. So I showed before, this is the formulation. What is that? This would be the formulation. So x, y, and z would be x times c minus c times y of the two vectors, etc., etc. But it's a little tedious. And honestly, I never remember it off the top of my head. So for this, I would just recommend you go straight with the RhinoCommon API. Okay. All right, and I think the lesson that I would like to do for this tutorial is I would like to show you guys how to create lines between points, for example. So let's get that going. Okay. Connecting wrong node. Yeah, I just realized. Thank you. Unitize Unitize could work like reparameterizing vectors. I'm not sure what you mean with that, Salvador. Like parameterize with vectors? Reparameterize? Oh yeah, like I see what you mean. Yeah, you can think of it that way, but I think you're pushing the metaphor a little too much, because reparameterize actually changes the domain of a NURBS object, but it doesn't really change the object. Whereas by unitizing a vector, you are changing the vector. You're making it much shorter or longer. So I would not. It's not entirely the same. I'm not. I don't. I'm not seeing. Yeah. Hari Prasad wants more vector-related videos in the future. Actually, for those, I'm going to recommend you check. I'm not going to do any of those time soon because I think the content of the playlist, the Harvard playlist, is already okay. So it's a good introductory lecture. So if you want to learn more, just go to that lecture and check it out. But yeah, maybe through examples, maybe through modeling stuff, I can talk more about vectors. Okay. What were we doing? Lines. Okay, yeah, that's probably the last thing we're going to do today, because it's a little late for me. So line, I'm going to take 2 points, which are going to be, for example, I'm going to take them from here. I'm going to take these 2 points. I'm going to construct a line between them. And these points are going to be whatever this thing is, whatever. I don't care. Okay. And a line and here. Okay. So now C sharp, I'm going to take in A and B, and I'm going to output L here and here, and I'm going to paste a panel here, and what else? Yeah, and the inputs. I'll do that in the video. Let's do this. Oh, you guys have to remind me to record the introductory video. Yeah, it's important. That's important. An introduction to the video. Okay, let's do this. And last but not least, let's do a simple line between 2 points. That's actually going to be super straightforward given what we've done already. So I already created 2 points, and I already have my line component in vanilla Grasshopper, and then I dropped a C# script component. I changed the names of the inputs and the outputs, and I still need to set the type of each one of the inputs to point 3D. Remember, this is very important. We tend to forget about this. I'm going to double click here, and then this is going to be extremely straightforward. Just like RhinoCommon has point 3D objects, it has vector 3D objects. It also has line objects. So we can create a variable of the type line, call line, lowercase line. And remember that C# is case sensitive, which means that uppercase line means the RhinoCommon class. So it's a type of data that we can use in RhinoCommon. And lowercase line doesn't mean anything for Rhino. So we can use that as a variable name. It's a little confusing, but you will see that happening quite often. So I can use the constructor syntax to create a new line object, and I can scroll through the options with my arrow keys. So I can use, for example, 2 point 3D objects. I can use a point and a vector to create a line. I can use a point and a vector and a length, and I can use the 6 coordinates of the first point and the second point. So X, Y, Z, blah, blah, blah. Because I already have the points, I'm just going to go for the first overload of the constructor and say I'm going to create a line between A and B. And then I'm going to output this value in my output L. And as I do that, Boom, I already have a line here in my viewport that is linked to the 2 points at the input. Great. Okay, so I think that's it. I think I covered less than I wanted to cover in this video. So maybe this is going to become part one of like a series of like, let's deconstruct some Grasshopper components and see how we could replicate that functionality with C#. Okay, so stay tuned for more videos about this. They will be on the link here in the comment section in the description. There might be a card popping up somewhere on your screen. And please remember to subscribe to the channel. And if you want to get notifications when new content is coming in, just click on the little bell, and so that I can nag you with emails like more stuff, more stuff, more stuff. All right. Okay. Thank you very much, and stay tuned for more in this series of GH Sharp, Grasshopper Sharp, or deconstructing Grasshopper components. Okay. Thanks a lot. All right. Yes, it always takes longer than expected. Yes, it always does. Absolutely, yes. So let's record the introduction before I forget, and then we can go to Q&A. Hey, Chris, I didn't know you were there. How you doing, man? I see you've been doing some machine learning. I want to hear what you're up to. Okay. Hey, Shireen. Hi, Kevin. How you doing, man? Okay, real quick before I get distracted, we get to Q&A in a second. I'm going to record the introduction. Okay, so all right. Okay. Hi, and welcome to what I believe is going to be the first part of a series of videos where I'm going to take regular vanilla Grasshopper components and I'm going to replicate them in C# with C# script components. When I say vanilla components, I mean all the components that you can find out of the box when you open Grasshopper, and which are probably the ones that you're used to working with. And what I would like to do is I would like to replicate them with C# so that we can learn what the paradigms are. I did not like that. Let me restart again. Restart. Hi, and welcome to what I believe might be the first part of a series of videos that I'm going to call GH Sharp or Grasshopper Sharp. Because basically what I'm going to do in these videos is that I'm going to take regular vanilla Grasshopper components, the ones that come out of the box when you download it and install it, and the ones that you're probably used to working with, and I'm going to mimic and replicate their functionality with C# scripting components. I think this is a wonderful exercise to do because it is a good introductory lesson to learning how to do computational design, but instead of using visual programming languages, starting to find and write the same logic with actual code. I think it's also a really nice exercise to get to know better how Grasshopper works internally, and especially to get familiar with RhinoCommon, which is the library, the geometry library that runs behind the scenes and that gives us all the power to work with points, vectors, lines, NURBS geometry, and all the real goodness. It's also a very powerful technique because if you have very complex Grasshopper definitions, writing them, condensing them inside C# components gives you a lot of performance, much better than just writing it with regular Grasshopper components. Okay, so this is going to be part one of a series where I'm going to break down, for example, the addition component, the numerical series. I'm going to do some basic geometry, so I'm going to create points, I'm going to operate with vectors, and I'm going to create lines. And you can see that each component has its mirror in C#, okay? And I'm going to explain from the very basics of how to do this. I want this first part to be a very introductory, beginner level video where I will take some time to explain what a C# component is, how to work with the inputs and the outputs, even though I will not cover too much in detail the actual C# programming language. I will hopefully have a series of videos at some point that you can reference to. Okay, so come on in and join me in creating or mimicking some standard Grasshopper components with C Sharp. Let's get done. Great. Okay, so that was it. How was that? Do you guys think this was useful? Did you learn anything that you didn't know? Did you find anything surprising? Would you like to see more of this, less of this? I'm open to Q&A, I'm open to questions. I'm going to give you 10 seconds because, you know, I speak and it takes some time to get to the chat, and it takes me some time to read it, and I need some water. All right. I see a lot of thanks. I thank you guys for being here and for sticking around for so long. But yeah, Pablo is asking why it's called vanilla. I did cover that already in the video at some point. So please look at the video at some point when it's published and then you can see. But it basically, vanilla is a term that is very commonly used in computer science, in programming languages. And it means that you're using what the programming language gives you out of the box without any additional libraries or plugins or anything. So I use the term vanilla Grasshopper to refer to the standard components that come when you install and you open Grasshopper. You have me on the hook. I loved it. Vanilla standard. Yeah, so people are chipping into the vanilla conversation. Okay. Thanks for the stream. Didn't know everything basically. Daniel is asking if I have a structural engineering background. I do. I am an architect by training. I did my architecture. I went to school in Spain, and architecture is very, very technical in Spain. We learn a lot of structures, and I actually worked as a structural consultant for several years at an engineering company in Spain. And I did work for architecture firms that were winning competitions in Spain. So we would be the local engineering to help them make their projects. So I did work indirectly. I did work for clients such as OMA, Mecanu, MDRDV, Cesar Pelli, like big firms that were winning competitions in Spain back in the times, before I went back to school and I got a bit more interested in computational design. Okay. Hey, Cody. Dude, when are we gonna see each other, man? I really miss you. Let's jump on a Zoom call and hang out or something. Professor Garcia, what do you recommend for me to look up C# syntax? That is a good question. So Microsoft MDN has, let me look this up. So Microsoft has the main C# reference. This is basically where you can find anything that refers to the .NET framework, which is where C# lives. It's complicated to explain the architecture, but let's say that C# is part of the .NET framework that is developed by Microsoft, which is what runs Windows more or less. But I don't think this is a good source for beginners unless you're looking for something very specific, like a function that you have read somewhere and you want to read, because it's so comprehensive and it has so much stuff that it actually requires that you know a little bit of what's going on and how to read this before this can be useful. So most of the introduction to C# courses that I've seen online are very computer science oriented. So you may want to check those out, but definitely I want to make like a list of tutorials at some point. I will actually start doing that very soon because I need that as well as material for my teaching at the GSD. So I want to make that out. I want to put that out as soon as possible. And maybe as somebody's pointing out, maybe I can, whenever that is done, I can do like a Python one, like a Grasshopper Python, or like a simple Python, and then how Python is handled inside of Grasshopper, for example. Grasshopper Tutorials is asking about Python as opposed to C Sharp. The thing is, Python is very popular, but it depends very strongly on what platform you're using and what you're using it for. Python is very popular these days as a scripting language in many environments, and is really good, for example, for machine learning. But if you're working with applications that live on the Windows ecosystem, you're very, very often going to find C Sharp as a scripting language. And that is the case, for example, in Grasshopper. It's the case in Unity, which is a video game engine that is very popular these days as well. It's very common, for example, with this new framework that I'm looking at. It's called VVVV, that they just ported fully to C Sharp. And I really want to make tutorials out of that. So it just depends on what you're going to be using it for. Software for FEA simulations. Multiple objects and not just single components. I have not been in that spectrum for a while. I was looking at that recently for a project that I'm working on this summer, and I didn't really find a good solution or framework. So I'm still looking into that. I may want to respond to that question at some point in the future. Maybe by mid-summer, I would be in a better position to respond to that. Did you ever, Thomas is asking if I ever use Blender, Tissue, or Svershok. I've never used, I know of Blender, but when Blender got really good and really popular, I was not really modeling 3D that much anymore, or rendering, so I didn't really get a lot of Blender exposure, but I've heard of Svershok, and I've been meaning to give it a try. Diego Pinochet from MIT is really good at Blender, really good at Python, and has a very interesting tutorials. I talked about him last stream or a couple of streams ago, so you can check him out. He has like some really interesting stuff. Rafael is wondering if I have worked with GIS or urban scale data. I've done some. I have had much less exposure to GIS than what I would like to. But the magic of all this is that at the end of the day, it's just numbers. It's all numbers. So if you know how to code and if you know how to manipulate like lots of numbers, GIS is just numbers at the end of the day. So it doesn't really matter that it's called GIS or which software you're using. You can use scripting and you can use code to perform the exact same functionality. So yeah, I've done some urban scale stuff just for data visualization back in the times when I was working in data visualization. So maybe we can do something like that. Maybe it can be one of the modeling challenges, like to model like we have like I don't know, like some topography, and we model like an urban growth on it, or we have like a set of sites and parcels, and then we just populate it with blocks and buildings and stuff. That could be cool. Suja is a Python person that is trying to get into C Sharp. I'm sorry, man. I'm sorry you had to do Python in your life. I'm joking. I'm just like joking about hating Python. but yes, I will hopefully write some videos about writing things in C Sharp at some point soon. When do you think the forum or website for the community might come out? Arasto. Hopefully next week. I promised it will be next week and I failed, so I don't want to promise, but I already have the Discord, I already have the website, so I just need to sit down and make it look presentable and come up with some like community guidelines or something like that, and then I will make it accessible to everyone. So come back next week, and we'll probably have already a Discord that you can join, and we can have the conversation there. In the meantime, I would like first to complete the transition to Parametric Camp as the main channel, and then take it from there. Parametric design of structures. Yes, Reynaldo, I'm definitely doing that, and I'm definitely doing that sometime soon because I think it's a really good exercise in computational design, and also when you're writing code in data manipulation and data matching. I think making Grasshopper definitions to draw trusses and triangulated structures, it's a really really good exercise for data trees, for example. So I really want to do that very soon. Yes. Compass. Ha, Salvador. So I'm actually good friends with Dr. Van Melle, who is the main leader in the Compass project. Compass, for those of you who may not know, Compass is a wonderful, wonderful project that is led by researchers of the ETH in Zurich from the Block Research Group, but mostly now it's gotten so big and so popular that the whole school is using it and contributing to it. It's led by Professor Dr. Van Melle and by Professor Philip Block, and it's a Python library for all things computational design. It's really, really cool. Uh, I'm just not an expert on it, but don't tell anyone. My secret agenda is to, at some point, grab Tom, the leader, and take him here to Boston and put him in front of the camera and get him to give us like a full tutorial of Compass. So just don't tell anyone. I need to make that happen at some point in the future, okay? All right. uh, Pixel car. Some he's saying that some of my videos from the GSD playlist have issues with the captioning. Yes, that is true because the captioning is automatic, and I have not been able. I don't have the resources or the time to sit down and rewrite those captionings. But I would be more than happy if anybody wants to contribute to translating or to like cleaning up. It's not translating; it's cleaning up the auto captions that that Google generates for the videos. I would be more than happy to make that happen. So more than happy to help that happen. So just reach out to me, and we can clean them up together, and I can give you pointers on how to do that. Do you think learning P5.js will set a good base for studying Python, C# in the future? I think learning P5.js is something you should definitely do because it's such a cool project at many levels. I am not sure. It's definitely. I mean, it's a good thing. I'm not sure if it's like the best way to start learning Python or C#, because P5 is very idiosyncratic. It has like a very specific way of how it gives you the possibility of drawing things on the screen, which is slightly different from how normal vanilla programming languages work. But it's just so cool as a project. Yeah, I mean, I learned how to program with processing, so I don't see why not. Maybe plain processing is a little better as an introductory platform if what you want to learn is C#, just because the two syntaxes are slightly are more closer to each other. Yes, because processing is strongly typed and JavaScript is not. So yeah, and what about Machina? Said is asking. Yeah, Machina. I will do a series of Machina tutorials. Machina is, for those of you who may not know, is one of my pet projects. It's a library for real-time robot control. The thing is, I'm working on that right now as well. I'm working on so many things right now that I never finish anything. That's my life in a nutshell. But I'm actually working on a set of features that I think have been missing for a long time. Forward kinematics, inverse kinematics, and simulation. And as soon as I get those done, I would like to now publish like a version 1.0 and then make like a serious comprehensive list of tutorials, which is kind of not there. Vakaris is asking what kind of music do I like. Ooh, okay. Personal questions. So, yeah, I used to be a DJ. I am sometimes a DJ yet still. So I do like electronic music a lot, a lot, a lot, a lot. My favorite genre is probably progressive techno. Um, but outside of that, I like trip hop. I like classical music a lot, and I like nice, chill, melodic music in general. Yeah. Okay. All right. I know just asking 3D voice processing. It should be done in Houdini. Ooh, yeah, Grasshopper is probably not a great environment for doing agent-based swarm simulation things, just because, like we did with the Game of Life example, you need to like write C# components and you need to keep them alive and do some. It's just not great. So processing P5, even Unity are like much better environments to do those kind of things. I will, whenever C#, let's learn C# playlist is done, I will continue with like a C# in Grasshopper playlist, and then probably the next thing I will do will be C# in Unity, which is a really, really nice environment to work with. So DJ mixtapes. I have a SoundCloud profile that you guys can check. So I have some mixtapes there. Yep. Uh, I'm kind of shy about that. But yeah, I mean, why not? So uh, actually, so this is my DJ profile. My DJ name is Brian Dre, and I belong to two organizations. Flight 6617. This is my group of DJ friends here in Boston, and the Mentha, which is my group of DJ friends in San Francisco. And we organize events and we organize parties and we go to Burning Man. Here you can see some of my own playlists. This one and this one are two of my favorite ones probably. Uh, and um, and yeah, you can follow me also on Instagram. I have a DJ Instagram. I don't know. Yeah, and this was me like much younger and without beard. You see, time, age. Oh my god. Oh my god. Okay, I'm gonna move. I'm gonna take this. All right. Uh, all right. Arasto wants to contribute to Machina. Uh, well, I mean, if you want, just reach out to me. There's a ton of stuff that you can do. We have a lot of work going on, so I will be more than happy. It's an open source project, so all contributions are always credited to the authors. So just reach out to me, and we can talk about that further. Kristen is asking why Brian Dre. That is such a long story that yeah, we can probably grab a drink and I can tell you about that. It's probably not a good live stream topic. It's a very, very long story. uh, all right, so I think with that I'm gonna call it a day because I need to have lunch and then I need to jump on meetings. So um, guys, ladies, gentlemen, it's been a huge pleasure. I thank you for being here all this long. See you next week. Hopefully, I'm going to push a bit more of media to like have everybody transition to the new channel. But we will probably see each other like here, there, somewhere else. You'll figure it out. Okay. So thanks a lot. Have a good weekend. Whatever you are, stay safe, stay healthy, stay fun. Okay. And if you do cool things with this, just like ping me. Okay. Thank you.